Let's graph this piecewise function. It says graph f of x, and in this set there's 2x plus 1 if x is greater than -1, and -3 if x is less than or equal to -1. The steps what we're going to do is we're going to graph each one, and then we're going to erase it based on its restrictions. Let's graph the first one. The first one is linear. It's linear because x is to the first power. In some simple ways, you can just write this as y equals 2x plus 1. And this is in slope-intercept form, mx plus b. So you're going to notice that our y-intercept is 1, and our slope is 2 over 1. Remember, this means a rise of 2 and a run of 1. Let's graph that. I'm going to graph using a pencil. So I start at 1 on the y-axis. And then I'm going to go up 2, rise of 2, run of 1. Rise of 2, run of 1. Okay? Just need a couple of points. Now, let's just say you ever want to go in this direction just to make sure your line is straight. You can also write that as -2 over -1, because class of negative divided by negative is a positive. So that would be down 2, left 1. Down 2, left 1. This is the graph of y equals 2x plus 1. Now, it does have a restriction. It says if x is greater than -1. So I'm going to highlight this -1 here. And I'm going to go to where x is -1, which is right here. And I'm going to draw this boundary. Everyone say boundary. This boundary is not an asymptote. It is not a vertical line. It's not part of the graph. It's just a visual of where a graph can and cannot go. So if it says x is greater than -1, and we draw a boundary, put your finger on the side where x is greater than -1. Numbers that are greater than should be on the right side. Because numbers are greater on the right side, I'm going to keep this side of the graph, and I'm going to erase everything to the left of my boundary. Let's erase it. I'm erasing it because I want values that are greater than -1, not less than. So let's erase it from the boundary to the left, on the left side. Pick your favorite color. Because this says greater than, not equals to, this will be an open circle at the boundary. So here, this is going to be an open circle. There's no equal sign there. And my graph looks like this so far. You can always go back and clean it up so you can see that it's open circle there. Alright, let's graph f of x equals -3. F of x equals -3. What's another way of writing f of x, class? Y equals -3. What does this mean? In a table of values, it's telling you all the y values will always be -3. And then you just make up some x values. Everyone say pencil. So let's graph this table of values now in pencil. 0, -3. Right 1, down -3. Right 2, down -3. Here is my graph. This is called a constant. Basically graphed a horizontal line here. From the boundary, it says x is less than or equal to -1. Point to the side that we're going to keep. Values that are smaller than -1 are -2, -3, -4, so we're going to keep this side. That means we're going to erase everything to the right. I'm erasing everything to the right because over here, these are values that are greater than. If you think about it, the super easy way, it tells you which side to keep. It's pointing towards the left. Does that make sense? Now remember, I'm erasing everything to the boundary. Pick your favorite color. Orange. And at the boundary, this will be a closed circle. It's a closed circle because it has equals to. I'm going towards the left. And this is our piecewise function. It has two pieces. Some quick ways to know if you've done it correctly. Not all the time are they going to be right on top of each other. It can be off. They will never overlap. You will never have a blue and an orange graph over each other like this. Okay? Let's take out your calculators. Show you guys some calculator commands to get the same exact graph. Under y equals, everyone say parentheses. We're going to put this into parentheses. So parentheses, 2x plus 1. And something that's a little bit different is the parentheses, and we're also going to press divided. Everyone press the division button. Zoom out, so you can see press the buttons. There's my division sign. And then I'm going to put in x greater than -1. X. Here's a new calculator command. I need to go to test. So I'm going to press second math. Class, what did I say?
Second.
There's my inequality sign, so I'm going to press greater than. Then your negative sign is down here. And then close your parentheses. Let's go down and do the second one. I have -3, so in parentheses, -3. Remember, do not press subtraction. Close the parentheses, divided by. Class, how do I get the inequality signs? Second math. Now, here I want to show you, if you ever have an inequality where there's 3 pieces and it's a compound, like x is greater than -1 and greater than +1, you can go over to logic and it has the words and or. Okay? So under tests, x is less than or equal to. Uh-oh. Made a mistake. So I was supposed to put parentheses x. So if you make a mistake like I did, I'm going to press second delete. That basically gives me insert because I'm lazy and I don't want to delete that and then have to go back. You can if you need to. So I have parentheses x. See what it did? And I have -1. Close the parentheses. Let me zoom in on the calculator commands. See them? And to get a graph, we're going to press zoom. What? And that graph looks just like ours. The common mistake for students, do not do it. Do not copy from the graphing calculator. It tells me you don't know how to graph, which means you need to learn how. The graphing calculator is here to help you check your answer. And that's how you graph a piecewise function, both by hand and graphing calculator.